World-class processing starts with our clients and the commitment they provide to their ultimate customers. Our teams thrive on solving challenges to unlock the full potential of resources through our services. Assessment of resource data and project needs to develop tailored solutions. Industry-leading engineering design founded on innovation. Project delivery that gears assets for prime performance. And operations that optimise production outcomes safely, profitably and sustainably. Success starts with truly integrated minerals processing solutions from a team whose passion is to drive global best practice forward.
Good morning or afternoon, depending where you are in the world. Ladies and gentlemen, I'm Steve Van Barneveld, General Manager of Strategy and Growth with Sedgman. Welcome to our discussion panel on current and future mineral processing and tailings management requirements and capabilities, and I'm sure some insights in the industry generally. Now, the panel will run for about 35 minutes, 40 minutes, and there'll be some time, hopefully, for some Q&A if we get time. But if you post your questions and if we don't get to respond to the questions, we'll take that offline later and come back to you. So thanks very much, Virginia, Patrick and Alan for joining me. I'm sure we'll enjoy some insightful commentary from your experience and forward thinking. So just to introduce more formally, we have Virginia Lawson, who has over 30 years of in-depth operational and technical experience in copper, nickel, lead, zinc and precious metals extraction across many technologies. She started her metallurgy career in small operations in the gold industry prior to working at Mount Isa, where she worked in both copper and lead zinc across a variety of roles, including the construction of several successful concentrator flow sheet changes and expansions to improve the performance. After Mount Isa, Virginia had the pleasure of 12 years in Sudbury in Canada in copper, nickel operating, technical and project roles until she returned to Brisbane with Glencore Technology, where she transformed the Jameson Cell market through its use in innovative flow sheet design, something that Sedgman is very interested in. Now with the Glencore Copper Group, she's working on establishing technical standards in the areas of project design, development and operation. Virginia holds a Bachelor of Chemical Engineering degree from the University of Melbourne and has published over 25 operations improvement papers and enjoys developing people and improving processes. Patrick Walter is a qualified metallurgist, mineral economist and board executive with experience across both technical and commercial roles within a range of companies, including Rio, Clean Tech, Citic Pacific Mining, Cradle Resources, Carbine Resources and Primary Gold. Also graduating from Melbourne University with degrees in chemical engineering and science, Patrick has gone on to complete an MBA, Master of Science and a Diploma of Project Management. In 2015, Patrick was awarded the Young Achiever of the Year at the Australian Mining Prospect Awards. And in 2017, he founded New Century Resources and became Managing Director following the successful negotiation and acquisition of the Century Zinc Mine in Queensland. And where they've gone on to restart operations, establishing Century as a significant zinc producer once again, while also facilitating the economic rehabilitation of the mine site, a really interesting development. And Alan Pangbourne, who has a lot of years, over 35 of experience in global mining operations, joined Chesapeake Gold recently. Prior to that, Alan was president and CEO of Guyana Goldfields through to its sale to Zijin Mining Group Limited in August of 2020. Previously, Alan was Chief Operating Officer of Silver Standard Resources, Vice President Projects for South America for Kinross, and held increasingly senior roles at BHP Billiton, including President and Chief Operating Officer of Nickel Americas, Project Director for BHP Uranium Division, which includes the Olympic Dam expansion, and the Project Manager for BHP's Spence Copper Project in Chile. Alan holds a Bachelor of Applied Science, Extractive Metallurgy, and a Graduate Diploma in Mineral Processing from the Western Australian School of Mines. So thanks very much, everybody, for joining us today. Really appreciate having you here. And maybe I'll just start with, firstly, Patrick. What are some of the key technical challenges in reprocessing a tailings resource, as you've done in New Century, as compared to freshly mined ore? And what solutions at New Century would you like to highlight?
Yeah, thanks, Steve. There's plenty to go through here. We'll keep it as tight as we can. Just to give everyone some background, so New Century has been successful in restarting Century as a tailings reprocessing operation initially. So we will eventually do some hard rock operations as well. But around that, we had nearly 80 million tonnes of tailings sitting there as a result of the historical operation. So we repurposed the existing infrastructure, and we've built Australia's largest ever hydraulic mining facility. So currently running about a 10.5, 11 million tonne per annum, and the goal is to ramp that up to about 12 million tonnes. So yeah, we do enjoy the fact that we are a hydraulic miner. It's not without its challenges, but when you think about the tailings dam or tailings dams as an ore body, they're beautiful ore bodies. They're fully constrained, typically no overburden. So you've got you don't have any of that those issues to deal with. You don't have cut-off grades. You don't have strip ratios, all that sort of stuff. And we're literally mining it with a high-pressure hose. So costs are a tenth of traditional open pit mining that occurs there. So all wonderful and sounds easy, but reality is there's plenty of art to hydraulic mining. Particularly, two things is managing the consistency of your feed to your plant, because you don't have a ROM stockpile. So we don't have 2 months of tailings sitting there in a big tank ready to be fed into the plant. We often have probably anywhere between 1 and 12 hours of feed sitting in feed tanks to the plant. So if you get a blip in your operations down at Hydromining, it goes through your plant. And when we're doing flotation for zinc, you need consistency. So that's a real key. If you want your plant running well, it needs to just be day in, day out the same thing. So yeah, one of the real key challenges with tailings operations that we've sort of discovered and gradually built competency in is trying to generate the consistency of that feed into the plant, and making sure that you've got that ability to control your plant, because you're not up and down like a yo-yo. So there are a number of mechanisms you can use for the reclaiming of tailings themselves, specific for reprocessing. We're obviously choosing hydromining. Dredging is another opportunity if your tailings dam is flooded. But again, you're still grappling with those same consistency of feed and flow issues. So you do have a lot more leniency because your costs are so low. So you can target much lower grade material. So the tailings dam at Century is about 3% zinc itself. You can also accept lower recoveries. For example, we're looking at around 50 to 54% recovery of that 3% zinc in the Century tailings dam. So lower recoveries of lower grade material because your costs are lower. But you do need to make sure that you get those operational efficiencies. The biggest benefit of tailings reprocessing at Century from an environmental perspective is the fact that we're actually facilitating rehabilitation while doing this tailings reprocessing operation. So ultimately, we pick up tailings that's in the tailings dam, which is an artificial or man-made structure, and we're putting them back in the pit. So we're actually facilitating that, obviously putting it via the existing plant, generating a return. But ultimately, we are facilitating rehabilitation, which is the goal of the business, is to generate economic activity and economic prosperity while also facilitating rehab. So yeah, it easy on paper is the summation, but not without its challenges. That's for sure, Steve.
Certainly, it certainly is it has all the hallmarks of a good news story. And I guess one of the things I do think about sometimes, and I think it came up in a conversation a few days ago, one does wonder that if you get to the bottom of that dam, what else you might find down there. I guess with a long history, there might be some interesting discoveries. But there are many tailings resources around the world, I guess, and we read about how many abandoned mines, resources that in terms of tailings, and I'm sure there must be more examples like Century. And do you think what you've achieved is now encouraging existing mine operators to seek to extract that value rather than abandoning those assets? Or are they, is it just going to, is it going to be more of the similar story where it waits for the innovative group, like yourselves, to exploit that residual value? What do you think the key drivers at play are, and how does your story impact on industry players?
Yeah, and 100%. I mean, we know of lots of other miners now that have had another look at their tailings dam, for example, because mining is not an exact or a perfect business. So you're always leaving behind opportunity, and opportunity tends to sit in the tailings dam. And if you think about that tailings dam, the amount of money that's been invested in it as well, that material's mined, crushed, and ground. So if you have legacy mineralization in there that's recoverable, it's much cheaper to pull it out and put it back through a plant. So there's opportunity there. The key issue, I think, particularly for large miners, is probably the hurdle rate of those investments. So, for large companies, they'll certainly look at tailings reprocessing and demonstrate a viable economic proposition, but it's still competing for capital against that, that virgin discovery that needs it there. So, I look, a classic example might be Cannington. Cannington, is a wonderful ore body that's been around for 100 years or whatever it happens to be. Has a really interesting tailings dam in it that's got some high grade, particularly silver at the bottom of it. Lots of potential for expansion. Reality is Cannington is competing with Hermosa for capital, now going forward. So, and if you're, on the board of South32 and you're looking objectively, say, well, what is going to be the pillar of my operations for the next 20 years? Well, it's in North America. It's not at Cannington there. So the old girl's got to fight for capital allocation. So it doesn't mean that it's not a really valuable economic opportunity there, but it's probably something that's better off in the hands of a focused junior, not New Century, could be anyone, not propositioning South32 to give us Cannington or anything like that. But, the projects have opportunities where a company like South32 or BHP or Rio can put up their hand and say, you know what, I'm probably too big to generate sufficient return to rehabilitate this mine site, or, to fix the tailings dam, whether it's picking it up and putting it back in the pit, or picking it up, reprocessing it, turning it into paste, and then doing paste fill of an underground. But we've demonstrated an opportunity where they can say, I'm going to hand this project to a focused rehabilitation company that is going to conduct economic rehabilitation. And that company can look at, obviously, tailings reprocessing, but it can also look at maybe there's residual mineralisation in the underground, or there's a cutback of the open pit that hasn't quite made the hurdle rates of that big company to be converted into reserves. So there's always a whole raft of opportunity. The 80-20 rule is alive and well in the mining industry, where those, companies will extract 80% of the value through 20% of the effort. But geez, the remaining 20%, when you've got these big mines like Century, that remaining 20% is still massive amounts of value there. And if you can use that value to create a double positive, you can unlock, for example, rehabilitation of the mine site by doing it. There's that double win scenario ultimately for the life cycle of the industry.
Yeah, well, that certainly outlines a huge, a lot of encouragement for groups like yourselves. Obviously, there's as you look around, there's a future of interesting opportunities. And I think the insight's interesting when you talk about larger companies in terms of that hurdle rate and where are they going to put where are they going to invest next. But it's just a great story where a group like New Century can come along, that type of organisation, extract the residual value, and along the way actually demonstrate strong environmental responsibility and social responsibility as well.
Yeah, and I just add, New Century has to a degree trailblazed this sort of industry, but as time goes on and the other people start doing what we've done, the hope is that we can create an industry where it's socially acceptable for a large company to effectively place their environmental liability in the hands of others, with a demonstrated record of being able to manage it, of course. Yep. But that if that can be done, then this mineralisation ultimately won't go to waste, and rehabilitation can be done more efficiently.
Thanks, Patrick. Virginia, actually, New Century just released some around the commissioning of their new Jameson cells at the New Century operation. And in Sedgman, we've enjoyed working with Glencore Technology more recently, seeking to leverage the application of Jameson cell technology and in combination with IsaMills in the continued development of base metals flotation circuits. So what are some of the benefits you see in this technology? And obviously, you've had a fair bit of time there in your current copper developments in your role now.
Yeah, thanks for that, Steve. It's interesting. I saw the press release on the Jameson cells restarting at New Century, and one of the things the deposits in that region of Queensland have in common is their very fine-grained nature, which actually enabled the development of the technologies to process them. I mean, without ultrafine grinding and technologies such as the Jameson cell, then we couldn't have effectively exploited them, or in Century's case, re-exploited them. So there's, that collaborative approach to development to solve a specific problem was very prevalent in the era that developed the IsaMill and of course, the Jameson cell. But looking forward, these technologies are not young anymore. I mean, the Jameson cell was developed over 30 years ago, the IsaMill over 25 years ago. These technologies are really just coming to the forefront. And some people say our industry is a little slow on the uptake, others cautious. But sometimes we just have to learn how to exploit these technologies more effectively. And I'm sure, once again, the New Century example shows that, the first time we did it, we weren't that effective, but we're able to go back and more effectively exploit it again now, which bodes well to the future in terms of companies accepting these technologies that for a while they saw as, although innovative, they're not in my backyard, I want somebody else to go and use it. But now that they're older, they're proven, they've become mainstream, it's a lot easier now to then apply it to new projects. And let's think about these projects a bit smarter. How do you apply these innovative technologies in the design phase to make a concentrator that's much smaller footprint? If you incorporate Jameson cells, IsaMills, you can make a very small concentrator with the obvious benefits that brings. Smaller footprint, lower energy requirements, obviously that translates into lower CapEx and OpEx. So these are some things that we're starting to investigate for both our newer greenfields operations. So some of the projects we're investigating bringing into production, we're going to look at how we can apply some of these technologies that were developed within Glencore. So we're very familiar with these technologies. But it's not just those, it's any of the emerging technologies that we see that will give us a significant benefit in terms of productivity of the mine, try and get that little bit more than that 80-20, the New Century story in trying to exploit it more effectively the first time by using these technologies very effectively. And working with people like Sedgman to design effective, efficient flow sheets early on in the processing chain.
I think it's, in our experience, obviously, Sedgman has a strong original foundation in the coal industry where, we were quite an early adopter of Jameson cell technology and it was extremely successful in transforming flotation performance in the coal sector. And as, through our diversification and our activities in base and precious metals now, we're extremely keen to continue to support, enhance new technologies for smaller footprint, higher efficiency. So a big focus for us as well. But what other innovative process technologies do you see making an impact in future copper projects? are there other things to make an impact on process efficiency, and also potential around tailings management and, in some respects, tailings mitigation?
Yeah, I think it's a really important question because, the copper ores in particular, we've seen for a while, they're becoming lower grade, they're becoming more complex, they're more likely to have deleterious elements or minerals contained within. So in the processing space, we have to think differently. And also associated with our social license, we can't necessarily afford to leave these deleterious elements for tailings to be reprocessed later. So it's our responsibility to look at this complex problem more holistically. And some of the evolving technologies, one example might be the coarse particle flotation, of the promise to enable us to deposit tailings at a much coarser size, to grind less of the deposit to very fine levels, gang rejection earlier in the flow sheet. All these things are leading us towards doing a better job of exploiting the resource, but also leaving behind potentially tailings that could be reused for things, focusing on what's important: energy, water. The zero tailings mine obviously is a dream, and maybe where we look at developing leaching technologies, either in situ or more novel approaches for mined ore. We're certainly, it's important that we continue to develop these innovative areas. I don't think there's any silver bullet because all deposits are different, and we do need to be able to approach each of these problems, using the scientific method and making sure that we apply the right technology to the right deposit. But I think we definitely need to look at working collaboratively with our researchers, trying to develop holistic solutions. And of course, in the data space, you look at the ability to measure things more sensibly earlier in the value stream. So, what can we measure from our drill holes? What can we measure to drive our processing earlier in the extraction process? So, look, there's a lot of work going on, and I think it's going to take a while for us to wrap our arms around it and bring it together into a cohesive path forward. But certainly looking forward to that.
I know that for us at the moment, there's a lot of interest around effectively the pre-concentration, whether through ore sorting or whether and through effectively grade engineering. That's something that I think also is going to add a lot of value in future in terms of how we assess resources and how we plan to process them. So moving to Alan, sorry.
No, I was just going to say that obviously if we can reduce the mass that we actually have to have impact on, that's huge.
Exactly. So interestingly, to move there to Alan, and I noticed the title of your corporate presentation at Chesapeake is Combining a World-Class Asset with Innovative Processing Technology, which of course fascinated to understand a bit more about that. And it goes on to say, greatly reduces environment footprint, producing green gold, which is an interesting concept in itself. What can you tell us about that?
So, Steve, thanks for the invitation. Where shall I start? Basically, as Virginia said, around trying to use less water, less power, and maybe not grinding everything to bug dust and putting it in a tailings dam so that Patrick can come along and have another go at it afterwards. We found a technology that allows us to heap leach the sulfides, the refractory sulfides that you commonly see in gold deposits, arsenic, pyrite, and the like, in a heap leach environment. And that in itself, it dramatically changes the water consumption, the power consumption, because you're not having to grind it, you're only crushing it to 1/2 inch. And then probably really important for local communities these days, there's no tailings dam. Because you put it in a valley fill and you engineer that, and that's where hopefully it all stays. And so, when we say the green gold, it's really based on that. The alternative processes for being able to get refractory gold out of the sulfides involves either smelting, roasting, or autoclaves, all of which are high intensity, use a lot of energy, use a lot of water to get you there. And in fact, if you've obviously, I hope you look past the first page in the presentation. There's actually some graphs in there where we looked at Barrick Gold's data, and you can see the difference between an operation like Pueblo Viejo, which is a autoclave plant, 100% production from autoclaves, diesel-powered electricity and large open pit, compared to Valadero, which is in Argentina, which is exactly the same, except it's a heap leach. And it's a 90% reduction in water consumption and power consumption. And anything that can do that allows you to significantly change both the environmental impact, the community impact around water sources for the local communities. As I said, no tailings dam, reducing power consumption. Power consumption is effectively CO2 emissions today, right? Until we actually get much more green available power into the grids, there's still, unfortunately, the final alternative, which is hydrocarbons. And given the location of a lot of these mines, we're not in Canada where we've got massive hydro resources. We're not in Australia where you've got massive solar resources. You come back to diesel, yeah? And so that's why we say it's green gold, because when you compare it to the alternatives, it is so much different as far as the environmental impact goes.
Yes, sure.
Yeah.
I guess I would encourage, and yes, I did read past the first page, and would encourage people to to read further, because I think it's a fascinating. I guess and what other innovative process technologies maybe are you thinking about with respect to Chesapeake assets, but what other technologies do you see making an impact on future gold and silver projects? What else is coming up?
I think, having listened to the other two speakers as well, I think the industry needs to start looking over the fence. The whole concept behind the technology that we're using at Chesapeake, apart from the chemistry where we do it in a 100% alkali environment, comes straight out of the copper industry. The copper industry has been oxidizing sulfides to recover secondary copper for 30 years. So look over the fence. Somebody's already doing it, and with all respect, I mean, Patrick, you may have made great insteps into the Australian business around hydraulic mining. The South Africans were doing it 30 years ago. So
and continue to do it a lot bigger as well.
Exactly. And so I think, when people talk about innovative processes and technologies, you mentioned the Jameson cells in the coal industry. We've got to start breaking down these false barriers between minerals and actually look across things, because there are all sorts of examples dotted around in the nickel business. The nickel business has started to move towards heap leaching laterites and getting away from autoclaves. It will have the same or similar impact as what we're trying to do in Chesapeake, and getting away from autoclaves. Yeah. So I think that's the first thing. What technologies? I don't know. I don't have a crystal ball. There are a lot of them around across multiple industries, but there are some holy grails out there. I don't know if any of you saw it outside of Canada, but there's a little company here down at the UBC called Jetty Resources, and they are claiming that they've cracked the chalcopyrite nut in a heap leach environment. Same again, massive change in the industry if you can do it and you're not relying on byproduct credits. Yeah. And so they're there. We've just got to look a broader, both within the industry, but also outside of the industry. And I think also the other thing that people often forget, when you start going into instrumentation and Wi-Fi and digital, last time I looked, most of our mines, unfortunately, are not in the CBD, and we don't have fifth generation cell towers next door. And so, some of the sites that I was involved in when I was at SSR, we were in the middle of nowhere, man. We didn't even have good satellite coverage.
Mm-hmm.
Yeah. And so, one of the things that often gets missed and forgotten is you've got to get the basics in. You've got to get Wi-Fi communication, or get away from just leaky feeders and get, in an underground mine, it's almost akin to turn the lights on so that your cell phones work, and then all of these other things that you want to layer on top of it can actually work. And then the next issue coming forward is you're starting to see the emergence of centralized control rooms. Yeah, it's been around forever in the oil industry, but hey, don't let the mining industry think they're not the first. You're starting to see them with Rio and BHP in Perth, and I'm sure they're probably looking at one in Brisbane. There's one in Santiago. You're starting to see these sprout up around the world in the mining industry. But again, they rely on connectivity, and
Exactly.
sometimes there's always a bulldozer that seems to find a fiber optic, and all of a sudden the lights go out.
Yeah.
And so there's some of those underlying basic communications and connectivity type issues that need to be addressed. And then, man, the sky's the limit with what you can do.
Yeah, Alan, I reflect on a conversation that I had with a young graduate process engineer once, who came to me to say, when it was time for him to do his rotation to actually go and work out on an operating site in our operations business, proceeded to tell me that didn't really quite work with his lifestyle, and he preferred to live in the city, which I sort of indicated, well, why did you study to become a process engineer? I think future technology may well encourage some of those young people that they can be more involved in the mining industry without having to spend all their time out there. But there's no substitute for that practical experience, I think. So, yeah. And any others, Patrick, Virginia, in terms of, the conversation there around future technologies, I guess. Any thoughts to add?
I'll let you go, Virginia.
I guess just on, thank you very much, Patrick. Just on that, one of the people is an interesting challenge, because yes, there is a desire to remain connected, live in the cities, which means they're often disconnected or aren't getting that expertise or exposure at the mine sites. And I think that is a challenge that we've seen during this year of COVID, that we can remain more connected than we originally thought we could, but we still need to take it to the next level. We still need better connectivity. We still need, whether it be the control rooms or whether it be able to interface directly with the operator on the floor, if there still is one. It's that connectivity I don't think we've solved yet. But certainly think that the human side of this is a really important one. I know in my kids, they're incredibly connected compared to, certainly what I was when I first got into industry. But it's developing those new technologies to take advantage of that connectivity and to take the mining industry forward, and match some of the things that are already being done in the oil and gas industry. And looking over our fence, I absolutely agree, Alan. That's really important.
I think what we hear a lot, in the drive for innovation, is collaboration is a big word, and I think that collaboration is what you're referring to, in terms of when actually start looking over the fence, collaborate with others, other industries, other sectors, to drive innovation. And sometimes it's not about some fancy new technology. It's actually about using something we already know to do something a little different, is driving the outcome. And interesting thoughts there. I mean, this is really coming from a service provision company that I'm. Intellectual property is always an interesting subject in that space. And I heard some refreshing comments from one of the more significant mining company leaders the other day around, that intellectual property should really sit with those that, or at least be shared between those that develop it, as opposed to, we often find as a service provider, when we seek to undertake a role for a client, that they always would love to own the intellectual property, which is always interesting. Any comments in that space from anyone?
Well, I mean, I'll start with intellectual property specific for New Century. We like to think we've developed some good IP, notwithstanding Alan's comments absolutely about hydro mining being used around the world. But the IP that we've generated is probably more, it's almost human specific, as opposed to a fancy widget or something like that. It's just the know-how and the understanding of that process is so vital that really puts you in a different position. It's probably less relevant for what New Century does in terms of IP ownership. We'd happily let Sedgman walk in and help us improve the process, because there's probably enough other barriers to entry where we're not too worried about holding on to the IP, to be honest. So that's our standpoint on it.
I think IP is an interesting subject, and particularly given that the process we've got is actually patent pending. So, but but I think very often what people forget is there's more to it than a patent. Yeah, the patent tells you a particular recipe that works. What it doesn't tell you is all of the other things that you tried that didn't work before you found the one that did. And that's where the value in that IP is. It's all the dead ends that you went down that you don't have to go down a second time, and hence why it's worth licensing some IP sometimes rather than trying to reinvent it yourself. Yeah. So it's an interesting double-edged sword. But the mining industry generally, in my experience, has been extremely open. I mean, there hasn't been a lot of IP, except when it comes to specific equipment or very specific processes. In general, we share best practices across the industry.
Yeah. So just turning the conversation a little bit more focused back into tailings management. With some of the recent tailings management failures that we've seen occur, and the increased drive toward alternate methods such as dewatering and dry stacking, we are seeing more companies consider that approach. Do you think there is a place for dry tailings when wet tailings and placement is still allowed? And do you think the social license will outweigh project economics with the regulators, even lenders and investors in the future, where approaches start to become mandated, or that you can't get a project funded unless you move away from wet tailings? What's your view on the path forward in that space?
I'll go forward. I'll go first if you like. I actually think there's a huge application for dry stack tailings. I think it will ultimately become the standard, particularly in comparison to other questionable innovative ideas such as deep sea tailings deposition and that sort of thing. Highly questionable on that. The reality is that there's new operations should be able to cover the cost of dry stack tailings solutions. It's only wet tailings is really probably developed out of laziness as opposed to anything else. The marginal cost of transitioning to dry stacking is not that big for a new development, for particularly for large scale mines. The issue then transposes over to what of existing operations. Can you start to pick up old wet tailings dams and dry stack them? And the difficulty there is you're talking about a net present cost argument, which one's got the lowest MPC. But if you can, again, start to apply more innovative thinking around, well, hold on, do these tailings have residual value in them? Can I reduce that NPC or even turn it into an NPV? In what I want to do is pick up a wet tailings dam and turn it into a dry stack tailings dam. Can I extract some sort of valuable mineralisation out of it to reduce the effects of that? There's lots of application for that, absolutely, because typically legacy mineralisation is left behind.
Mm.
Yeah, I think. Sorry.
No, go, Virginia.
One of the other areas of that, though, is I'm not sure it's going to switch on, as in we go directly from wet to dry. And I think some of the ideas you spoke about earlier with pre-concentration and trying to reject as much gangue as early as possible means that there's potentially a transition path whereby we're able to dry stack a portion of our tailings or repurpose a portion of our tailings and minimise the portion that's stored as wet, potentially reprocessing. But I'm not sure that it's just an on-off argument. I think it's one of the areas we have to evolve. And as the front end of the flow sheet evolves, mining less or processing less, rejecting as much waste as possible earlier in the flow sheet, grinding to the coarsest possible size and making a free draining, stackable waste material for potentially for reuse, and then only a small component which has to be processed in a more complex way. I think that's one potential path forward, but obviously I think if we look into the future, I think we'd all prefer to minimise water, minimise potential of contamination, and be able to walk away from a mine when it looks exactly the same as it did before we started exploiting the resource. It's just not going to happen overnight, and we need to be doing the work, both the research work, the development work, and the application work to be able to see the vision of how that's going to happen and how we're going to transform the industry and develop the human capital that helps us do that.
I think, and I'll turn over to Alan in a second, but I think that what we're seeing is first is that there is a lot of work needed to be done in equipment technology around that space of dewatering tailings, and even there's some conversation during this conference around technology that is enabling the recovery of finer and finer particles of valuable mineral, and therefore sometimes reducing again the size, grinding to bug dust, as Alan said before, which makes it even more challenging. Fundamentally, and Alan, I'll turn to you. You made a comment to me the other day around dry tailings. They're not dry.
Exactly, and I think I don't think there's a single solution that fits all, and there never will be. And often people, certainly outside of the industry, that don't understand that dry doesn't actually mean dry. And there are sites around the world that have been using dry stack tailings for quite a while. Some of them, unfortunately, unlined and have now got some rather interesting, not very nice metals creeping down valleys in different places. So, it's not the be all and end all. I think where the industry needs to go, and you've seen it in different places, it'll end up being collaborative. Some of it will be permitting pressure to not do things, and you've seen mines in environmentally sensitive areas that have deliberately permitted a flotation route rather than the cyanide route. And you're already seeing that, and I'm sure people can name several. Yeah, you're seeing in certain jurisdictions, you cannot build and get permitted upstream construction anymore. It's gone. Yeah, so that's the legislative side of it. So I think you're going to see this sort of meeting of the minds somewhere in the middle of what is socially acceptable and what isn't, what is legislatively acceptable and what isn't. And then, as you said, it's all well and good to say dry tailings is an answer. Try doing that at 200,000 tons a day with the current technology. You can't build enough filters fast enough or keep them running. Yeah. So there's things like that starts causing issues. That the scale of some of these mines around the world, there isn't an alternative. But I think there needs to be a bigger focus on the ultimate closure. How am I going to close it and be able to walk away from it and hold our heads high that we've done the right thing, and not find it halfway down a river valley in 50 years or 100 years, or maybe even 10 years? Yeah.
Yes,
And there's a responsibility there that we've got to take on. Yeah,
no, for sure. And I think most definitely, and I can tell from personal experience that the most recent dry stack tailings, actually, our managing director Grant Fraser was talking earlier to Mike Cicilio from Nevada Copper, and I can tell you that at Pumpkin Hollow, it wasn't the easiest part of the process plant to commission and make work well. Was drying those tailings. It's always going to be a challenge. So, but how do you see, I guess, comment from any of you, I guess that the balance, economics versus social license? I think the comment before, all new projects can afford to be environmentally responsible, but in terms of the additional cost, where does that cost get borne? If the cost increases, it get borne in the commodity pricing? Who's bearing that?
Ultimately, the market will. You need the metals, whether it's for copper, for electricity, silver, for solar cells, whatever it is. As the costs get moved up and the social license, you're already seeing it in some of the energy pricing. And then once solar started taking off, the unit cost came down again. And now it's cheaper than carbon. So, I think the market will sort it out for us. And those projects that aren't economic, won't be socially acceptable.
I think it's going to be interesting as we're hearing about the critical minerals, and as we move into some of these new commodities, that equation with very small markets, and in the emergence of new commodities, it will be an interesting path forward around the economics. I guess the last question, just wrapping up, and if there's anyone listening who wants to post a question, please feel free to. We might not get a chance to answer it today, but I just wouldn't mind going around the panel and really just wrapping up with a question around digital technology. Virginia, you talked a little earlier about data and but how do you see digital technologies integrating into existing and future mineral processing plants? I know, Alan, you'll make a comment about, first thing you've got to do is switch the lights on. But how do you see the path forward in that space?
I think it's a really critical path forward, and to some degree we don't know how far we can go until we start going down that path. In some cases, we measure what we can rather than what we need to. And so there's definitely space in developing the right sensors and tools to start measuring what we need rather than what we can. And once we start doing that, then I think the acceleration of the digital age will be quite quick, because we need the information, we need it readily available to be able to make the right decisions, and to be in control of this ever-changing process. So we need to get the infrastructure right so that we can rapidly adopt the changes as it's happening.
And to follow on from what Virginia said, the key there, as you say, is developing digital technology, digital data, probably inside processing plants, to enable a focus on feed forward control rather than feedback control, which a lot of the time when you've got manual processes like sampling for a lab, it's whatever turnaround time, and you've lost 6 hours of runtime. So the more online and digital things become, the more feed-forward control will be available, and the more efficient operations will become. It's as simple as that.
That's great. Alan, I'll give you the last word.
I think, there's a mountain of data that's already collected when you look at a mine site, between data off the drills, the trucks, the dispatch systems, the process systems. It's an absolute tidal wave. One of the biggest issues I've seen as we've tried to wade through it and find the gems in it is cleanliness. Industrial data is inherently extremely dirty. Yeah, and it takes a lot of time and effort in data cleaning. I had some master's students, they told me they spent 70% of their time data cleaning and 30% of the time working out what it was worth.
Yeah.
Yeah?
Yeah, no, for sure.
But it's a gold mine. It is a literal gold mine, what's out there.
Sure, for sure. Well, thank you very much, everyone. We've only got a few seconds to go, so really appreciate your participation and contribution. Thanks for your insights, and it's going to be an interesting path forward in this space. So look forward to catch up soon. Cheers, everybody. Thank you.
Thanks, everybody.
Thank you. Bye.
Bye.
World-class processing starts with our clients and the commitment they provide to their ultimate customers. Our teams thrive on solving challenges to unlock the full potential of resources through our services. Assessment of resource data and project needs to develop tailored solutions. Industry-leading engineering design founded on innovation. Project delivery that gears assets for prime performance. And operations that optimise production outcomes safely, profitably and sustainably. Success starts with truly integrated minerals processing solutions from a team whose passion is to drive global best practice forward.
I love coming to IMARC. The buzz here is great. There's so many new and interesting people to see, lots of great opportunity to network.
The value of IMARC to us is that we can get an update of a lot of the companies that we have invested in or are looking to invest in. In a broader picture, we can get an update on the new technology that's happening in the mining industry.
I've been to a lot of conferences and this is probably the best I've seen. It's definitely the biggest for sure.